So here's a problem where we've got vectors meeting projectiles. So the IJ notation for a vector being used to describe this problem. So let's see how we get on with this one. So I'm just going to draw a little picture to start with to get my head around this problem. I've got my x and y axes, the I and j directions here, then my initial velocity is something like that, 13, 4. So if my origin is here, my particle is going to go something like that. And the point K, the point that it passes through is as a multiple of the vector 2i minus j. So that's something like 2i minus j is something like that direction. So that's the point there that we're interested in. So I need to look at the horizontal and vertical motion of the particles separately, and then somehow find a way of joining them together to find the single solution where they meet. So if we look at the vertical direction first, then we know that the displacement is going to be 2k at the point where the horizontal and vertical components of the motion meet. So the horizontal component is 2k there. The initial velocity is 4 because that's the j component of the initial velocity, because I'm looking at the vertical direction here. Not interested in the final velocity, and the acceleration is minus 9.8. And what I'm saying is that the point at which they meet, I'm calling the time capital T. Horizontally, at the time t, the displacement horizontally will be minus k, because that's k times minus 1j. The initial velocity is 13, and the acceleration is 0. We're not interested in the final velocity. So for both of these, I can use the same formula, which is the formula which doesn't have the v in it, and that's s equals ut plus half at squared. So when I apply that formula to the vertical data, I get that, and to the horizontal data, I got that. So now I need to just simply start by solving these two equations simultaneously. So what I've done here is I've rearranged this formula to tell me that t, capital T, is minus k over 13, and I put minus k over 13 here and here, and that gives me this equation here. Now it doesn't look terribly friendly, but it's just an equation that's a quadratic equation in k. It's got two answers. One of those is 0, but we're not interested in that answer because that's the origin where the motion starts. We're interested in the other value, which is that number there. So we found the value of k. Now we need to find the distance from the origin at that instant. Well, at the point where the components of velocity meet this vector here, we know that the horizontal displacement is 2k, the vertical displacement is minus k, so that's 2k there, that distance there is k, So we're looking for this distance here, if I call that d. That's the distance that we're looking for. So it's a straightforward application of Pythagoras. So the x displacement, the horizontal displacement, is 3900 over 49. The y displacement is that number, and so the distance from the origin at the point where the particle passes through that point is that horrible looking thing, but thankfully calculators take that all in their stride and give us the final answer to 1 decimal place there. So there we are.